All right, Kurt, you asked about the oil coolers, so the whole story, here we go. And if you guys, once again, if you guys get bored, hit the forward button and get on to the next thing. But here we go, deep dive, best I can recall, my version. So the leveler guys put the oil coolers in the gun base. When you take this thing apart, 3 screws, this leading edge comes off, and then there's holes in the spar where the guns can go down there through it, right? The back, this bottom panel comes off. That's the shell ejectors for the empty casings and the flap right behind it. Okay, so if we move to the top, you've got the bubble. Where the bubbles are, that's where the blisters for the guns, right? That just comes off. This yellow part comes off on top of the flap. So this whole thing just opens up and there's a big ass hole that goes right to the floor. So the leveler guys and the gun bays where the bullets the whole 9 yards went in here. So that all opens up. So they were able to sink automotive type coolers. They were maybe 8 inches square by however long. They stuck into both sides by maybe 2 feet. About 8 inches, 10 inches square, something like that, by about 2 feet. And then the oil lines came in from under the airplane, right? And so they were automotive, that was fine. The leading edge, they simply took the holes where the gun ports were and just left the holes, basically, right? They didn't know about the aerodynamics of it. And so that's what they did. The exit, and instead of making it exit on the top like stiletto, they exited it on the bottom. And as I look at this, I wonder why, because they could have just come right up here in front of the flap. Could have come off the top instead of the bottom, and to me that's a low pressure area, and it would work. And as you get your angle of attack up, you're gonna have an even lower pressure. So they had doors here which exited right here in front of this is the flap here, and they had doors that opened and closed with some monkey motion. I do have little parts left from that monkey motion that are cherished possessions of mine. Anyway, so the leveler guys did that. They never had, I don't know how they got it to to Reno from Arizona, being that the coolers just didn't work. And Skip said when they were racing, they had telemetry, and he complained about the oil temperature being high. And they said, they put a piece of tape over it and said, we'll handle the oil pressure on the ground, or the oil temperature. We'll let you know if there's a problem. And they were going to change an engine every night anyway, right? So no big deal. So that was the leveler guys. And then the airplane got sold to Bill Woods, who was an airplane Steve Boland, and then went to Bill Woods, an airplane trader up in, I think, Redmond, Oregon. And what he had done, knowing that apparently he flew it or something, or figured it out that the oil coolers just didn't work. So their guys opened up the trailing edge. And I'm not sure that a picture exists of it, but basically they just split the trailing edge here on top of the flap, because flap's right below it, and just gave it a gap of about 2 or 3 inches all the way across with little fences here. So just a ramp basically, and it just exited the air out the back. He made it to Reno, and it seemed whatever. He made it to Reno, bellied it in with the gear up, with the gear partially down. That's how we got it. So then fast forward to when we get this thing running, we're over at Lincoln, Dad's doing the test flying. He didn't fly very long ever. Didn't complain too much about it, although maybe it did get hot all the time, but the flights were real short for the test flights, plus getting his check ride from the FAA. None of those lasted more than 10 minutes, really, 10, 15 minutes, and then put it back on the ground and be done. So maybe he was complaining the whole time. But when I think this was right before the first Phoenix 500 air races, because he went into, he departed out of Lincoln and headed for Auburn and Mayday off the downwind into Auburn with a really high oil temperature at that point. And it's like 15 miles straight line to Lincoln, so it ain't far. So the oil coolers were not working. And in fact, I think we already knew that, and we had done a mod to, according to Bruce Boland, we had opened up the front end of the intakes, and we had just scabbed on some metal to try to drive some air through it at speed. And that didn't seem to help, which led us to believe that the oil coolers just weren't doing their job, that maybe the 60 weight couldn't get through a conventional automotive oil cooler. I don't know. That's my recollection. So Mayday's in. My recollection is we did not go to the Phoenix 500 air races. I did in the T6. We'd already launched the truck and the trailer, so we had all the support equipment there, and we all flew in. But we just were missing the Sea Fury. I raced the T6, the yellow airplane, and yellow Yankee Air Pirate, and that was fun. And then we headed for home. So what's the next step? I got my notes here. Bill Woods. Then we got some 1820 oil coolers from Dennis Buin up in Carson City. He was an Albatross guy, T6 guy, Albatross guy, and he had some 1820 oil coolers, and I think that was what the Super Corsair ran, or somebody ran those, and we got tipped off to use those, so we used them. One in each leading edge of the wing, right? Outboard of what would have been the oil cooler, no, what would have been the air inlet right here. So these were basically covered over, and they were, this whole section was pretty well beat from the belly landing and whatnot, and this piece is up on the shelf. Someday I'll show it to you, and it's just hammered from the belly landing that Bill Woods did at Reno. But basically we just took this piece. Once we removed the leading edge here, which is a fuel tank, which goes all the way out to the wing fold, we just moved this piece outboard to here. Is this right? Anyway, this is my recollection. And then built the new insides. But in any case, I don't think the first go around worked, or maybe Jimmy had the time now to put on, this makes more sense. He put on, as if you'll recall, the fences that were on there. He scratch built, this is it, he scratch built oil coolers that hung there. Started with aluminum angle that he bought at Home Depot, and then actually, what was 84 Lumber in town, and then Lumberjack, actually, if you can remember that, in California, and then built up these oil cooler hangers, the entire structure. And it had, like this one, it had a door that moved, right, that opened on the back, but it also had a bunch of monkey motion and had a door that closed in the front. I don't remember whether it went up or down, but it came to probably up, probably came down, and it closed in relation to the door in the back, and they opened and closed together. Okay, so it worked, but aerodynamically not the best. And once we got to Reno, nobody was impressed with it. And Bruce Boland came over and said, here's what you really need. In fact, he may have shown us this at, it was definitely on the Super Corsair, and it may have been at Phoenix, and there may have been a conversation there. I'm sure we started that conversation. But we went over to the Super Corsair and looked at what they had done for their oil cooler ducting on the Super Corsair. And then Bruce Boland was able to come up with a drawing, like his specs that he used to give somebody to build the original Corsair, because they're, right, engineers, right? So the drawings were there. So somewhere we've got the engineering drawings to build the inlets for the Super Corsair. And Jimmy took that and he built them. And he built them out of fiberglass. And they're on the shelf up there in a different hangar. And he built those for the inlets and left the exit door that's movable and went the inlets. And the reason it's important on the inlet, as I alluded to in an earlier video, this radius has to be right because the air spills over, right? It doesn't all go through the cooler at any speed. It dams up and goes around, and the air needs to go around, and it needs enough of a radius on these leading edges in order to spill out. And you can see that here too, on the air part. And it was all calculated. So then we had 1820, a pair of 1820 oil coolers, one in each leading edge, with the Super Corsair ducting, and worked beautifully. Never had any trouble. Dad had hooked up 6 oil temp gauges, and this is story 2, to see, I think 6. It was, he had his normal oil temp, and then he had ones, the inlet, the outlet, the in cooler temperature. He had a bunch of them. Had a little 6-position, probably an EGT gauge that had been hooked up for this purpose, and he could switch through all the, cycle through all the oil temperatures to make sure it was running right and that they weren't bypassing. And the reason the bypassing was important was because the Dreadnought guys had told us a story about core locking the oil coolers in Dreadnought. And Dreadnought runs stock oil coolers, I believe. In fact, I know it does. And at least it does now, and I assume the whole time. Runs a pair of them. But what had happened, I believe, was Rick, killed in the pond racer, Brickert, had started coming down the chute actually, and he turned on the water when they were still in the formation getting ready to come down the chute. Turned on the spray bars. And what it did was it congealed the, how do you say this? It cooled the 60 weight oil in the cooler enough that it congealed the oil and it stopped flowing. So there's a bypass on it, so it bypassed the oil cooler like any airplane should. If you get an oil cooler blockage, it'll just bypass it. And that's what it did, which is fine, but you're going to start the race and then your oil temp's going to go out of sight, right? Exactly what happened. So he Maydays out of the race because of that. And so they never again turned the spray bars on until you get the power up. Get the power, you have a race, get the power up, get the spray bars on, as I believe the order. And they told that story to everybody to make sure nobody else had to Mayday out for that stupid reason. So kudos to them for sure. So where does that get us to? That gets us to us and having one that works well. Now, this sort of ties in with the inlets on the, this is a fun story. So we changed the inlets, right? If you look on the later critical mass, it has an air intake here. Question is why? Some of you know. Originally we started with the A26 cowling that the Leveler guys had, and that had a ram air scoop right on the top, like Dreadnought, like the Rare Bear did some periods of its life. And it just rams it right down the carburetor. Piece of cake, works great. Makes a lot of manifold pressure that way. But Dave, when they put the big motor on the Rare Bear, Dave Cornell spec'd a DC7 cowling because that was the best aerodynamic and the best one that was going to fit. That doesn't have an air scoop on it up top. So he went back to this here. And got that going. And it didn't quite make as much manifold pressure, but it was a lot cleaner aerodynamically. I don't know. He was happy with it. It was cleaner for sure with the DC7 cowling. And so we did the same thing. When we put the Rare Bear motor on critical mass, with Dave's consultation, he became a race engineer, and Dave Cornell took care of us. Wonderful guy. And we did the same thing. Put the air intakes back where they should be stock. So we had two air intakes inboard, two oil coolers outboard. Now, one interesting point, and I think that's the story of all I have on the oil coolers, but I have one final story, which is if you look at the Rare Bear, where are the oil coolers? My recollection is they're a little farther out on the wing, right? If you look at a Bearcat, there's the scoop. Is the scoop inboard? I don't even know anymore. But somewhere a little farther out on the wing, there's it's probably like this one, probably an air inlet and an oil cooler scoop all together. And I think the oil cooler is inboard behind the engine on the Bearcat. But in any case, I asked him why he had never done a boil-off system. And he says, we can't afford to. And I said, why not? And he said, because the wing's too fat. And I said, what does that mean? And what does that have to do with the oil cooler? And the answer is, if you look in the NACA report, the NACA reports from the 40s, and I looked them all up and read them all, well, all I could find and all that applied, there's a theory that if you have a fat wing like the Bearcat does, Sea Fury's a much thinner wing, if you have a fat wing and you draw air from the leading edge of it and make it disappear, it behaves like a much thinner wing. So he always wanted the air in that area at least to come off and be stolen for the oil cooler and for the air inlet. And then what you end up doing is allowing the airplane to be faster, not because of horsepower, but because of the drag of the wing, because that wing is so fat. And he always said, just shook his head when the new guys did they put a boil off on it. And it made me shake my head because I was like, oh, there's a reason that he left that there for sure. And it didn't have anything to do with, we're going to just clean up the oil and give it a boil off and it's going to go faster. It had to do with the wing, the Mach limit of the wing itself. And I don't know the answer of which was faster and whatever else, but that was the theory land. So that is the deep dive. For all you geeks out there that joined me, congratulations. There you go. Hit me up with comments on something else you want to know, and I'll do my best. Cheers.